In the first day of the matrices unit, we are going to have a fairly broad overview of a lot of different concepts of matrices. So I'm going to go through it here, and some of the work will be calculator work, but it will get more interesting and slightly more elevated in difficulty level in days 2 and 3. But in terms of matrices, we want to start with, first of all, a matrix is singular, matrices is plural. And the dimensions of the matrix represent the number of rows and columns, and we say row by column like that. So we always read the matrix row by column, and I do abbreviate that R by C. So in this matrix, we have 2 rows right here, and we have 1, 2, 3 columns. So the dimensions are 2 by 3. The numbers in the matrix are called entries. These are the entries of the matrix. They're also called the elements of the matrix. So if I ask you what the entry is in the second row and third column, you come right here to the 5. Okay, so we just go row 1, then row 2, second row, first column, second column, third column, and we look at the element that's right there. Okay, so there are different types of matrices. A row matrix will be a matrix that is all the elements in just one row. And I'm going to give you an example, say 1, 2, 3, 4. That is a row matrix, and that meant to be at the example, and the description is just one row. Sorry for the handwriting here on my mouse. Now, a column matrix is one when there's just one column. So an example might be like this, like 4, 6, 8. And again, I switched the order. I meant to put my description on the left and my example on the right, but that's okay. So a column matrix is just one column, and that was really largely written. I didn't mean it to be that big. Okay, so a square matrix is going to be a matrix with the same number of rows as columns. And so this would be a 2 by 2 square matrix. Here's another example of a 3 by 3 square matrix. So same number of rows and columns. And I misspelled that, but you'll forgive me. A zero matrix is one where every entry is 0. All right, so moving on. Matrix operations. In order to add and subtract matrices, the matrices must have the same dimensions. And what you're going to do is add or subtract corresponding entries or elements. Then scalar multiplication is when there is a constant on the outside of the matrix and you multiply that constant to every element or every entry inside the matrix. So let's do some work here. Perform the matrix operations indicated. So I have an addition. So that means I take each corresponding pair of entries and add them. So 6 minus 10 is -4. 5 plus 8 is 13. -2 plus 13 is 11. -3 plus -9 is -12. -2 plus 1 is -1. 0 minus 7 is -7. Problem 2, we're subtracting. So we subtract corresponding pairs. So 8 minus 2 is 6. 3 minus a -7 is 10. 4 minus 6 is -2. 0 minus a -1 is 1. And then down here we have scalar multiplication. So we take this number 3 outside and we multiply it by every single entry within the matrix to get this new matrix. And then we get slightly more complicated on number 4 because we're not only doing a scalar multiplication, but then we're adding. So the way we'll handle this is for each entry, we'll multiply first by -2, and then we'll add the corresponding entry in the second matrix. So we have -2 minus 6 is -2 minus 4 is -6. -2 times -2 is 4, plus 5 is 9. -2 times 0 plus 6 is 6. -2 times 3, -6 minus 8 is 14. -2 times -8 is 8, minus 2 is 6. -2 times 5 is -10, plus 6 is -4. Okay, so those are the two, let's see, I just realized I made a mistake here. -2 times 3 is -6, plus a -8 is -14. Sorry about that. So those are the two most basic operations that we'll be dealing with. Now one thing that I can do, now we're going to go ahead and solve this matrix equation for x and for y. So let's just look at the corresponding elements of each matrix that will involve the x, and we'll set up a little algebra equation with just those. So we have 2 times 3x is 6x plus 4 equals 26. So 6x equals 22, and x equals 22 over 6, which is 11 over 3. Then we can separately do all of the elements that deal with y. We have this guy, and this guy. So we're going to have 2 times 5 is 10 minus y equals 8. So that means that y equals 2. All right, the next thing we're going to work on is matrix multiplication. Now, matrix multiplication by hand is quite the interesting task, and we're not going to actually do that in this class. We're going to rely on our calculators, but we do need to know when we are allowed to multiply matrices. So in order to multiply a matrix, let's see, I need to close that, open a new color. Here we go. The number of columns in the first matrix must match the number of rows in the second matrix. So if A is m by n and B is n by p, the product of a matrix AB is m by n times n by p. Do you see how the number of columns here and the number of rows here must match? And as long as they match, these will effectually cancel out and we'll be left with an m by p matrix. You'll be left with the number of rows from the first matrix by the number of columns from the second matrix. Again, we will not do matrix multiplication by hand in this class. But if I have a matrix A that's 2 by 3 and a matrix B that's 3 by 4 and I multiply them, the interior dimensions will cancel out and my matrix will be a 2 by 4 matrix. And then for this one, do you see how the interior dimensions do not match? Therefore, this matrix multiplication is not possible to perform. All right, so let's do multiplication of matrices on the calculator. And we must follow the order given because matrix multiplication is not commutative, meaning it's AB will not be the same thing as BA. First thing you need to do is learn how to put a matrix in your calculator. So here is a TI-84. What I want you to do you see this blue here that says matrix that's on the inverse button? You're going to go to second matrix, and then I want you to scroll over to edit, and then we're going to edit matrix A. So we hit enter, and we want to tell it to be a 3 by 2, 3 rows by 2 columns. So we punch in a 3, enter, 2, enter, and then we have to type in the elements. -2, 3, 1, -4, and just note that each time I'm hitting enter, 6, 0. Okay, now I've got my complete matrix. Now I have to second quit matrices and then hit second matrix to go back in. You see now I've got a 3 by 2 matrix in A. Scroll over to edit again and now go down to matrix B. And in matrix B, we're going to put in a 2 by 2. So we type in 2, enter, 2, enter. And then we'll put in the elements of the matrix, -1, 3, oops, I put in a decimal, let me erase that, -2, and 4. Once again, before I start multiplying, I need to second quit out of the matrix. Now go back to second matrix, and we're just going to take A times B. So this is A. I hit enter to pull A to my home screen, go back to second matrix, and choose B. Hit enter, and now I've got A times B, and there it is. Now if I try to do B times A, I go second matrix, I choose B first, and then second matrix and choose A, and it says there's a dimension mismatch. That means that this multiplication is not possible. Okay, so that's what you're going to do on your calculator for matrix multiplication. Let's go back to the lesson, and again, we're just doing an overview of a lot of different things in matrices. The next item that we're going to look at is a determinant of a matrix. And a determinant of a matrix is just a number associated with the matrix, just a number. And we're going to use it for other things, but it doesn't represent anything other than the number associated with the matrix. And we denote it the determinant of, whatever matrix it is. A determinant of a 2x2 matrix is kind of fun. You take A times D minus C times B. You take that little loop-de-loop. So AD minus CB. So if I want to take the determinant of, or find the determinant of number 10 here, I do -6 times -7 is 42 minus 1 times 2. So the determinant is 40. Same thing here for number 11. Take 1/2 times 8 minus -2 times 4, which gives me 4. Let's see, -2 times 4 is -8, times -1 is 8, so 4 plus 8 is 12. Notice also, I wrote here determinant with the parentheses. This, what looks like absolute value signs here, that also denotes determinant. So this is telling me to take the determinant of the matrices in numbers 10 and 11. So getting the determinant of a 3x3 matrix is a little bit trickier. So basically the first thing we do is we take this value A, and then if I cancel the row and column that come with A, and I focus just on this, I basically need to multiply by the determinant of that. So EI minus HF. Then I'm going to erase what I had here, go back and look at the second item in the top, cancel the row and column that come with that, and find the determinant of what's left. The B value becomes a scalar in front, and I subtract this time. I have to go plus, minus, plus, and I would keep going if I had more columns. But I have the B value then times DI minus F times F. So DI minus F squared. And then go back to this, and I'm dealing with C as my scalar, so plus C, and then cross out the row and column that come with C and find the determinant of what's left. So DH minus EF. So that is how you find the determinant of a 3x3 matrix. The beauty is that we're going to be doing that in our calculators. So if I want to find each of these determinants in my calculator, what I'm going to do is open up my calculator again, and I have to go back and I have to enter each of the matrices in my calculator. So the very first one, I'm going to go to Edit, and I wanted a 3x3 matrix, so I have a 3x3, and remember after each item I have to type in the enter sign. So 4, 3, oops, didn't want that. Let's go back to my matrix, editing the second one. I have a 4, 3, and I need a 1. And then I have a 5, a -7, and a 0. And I have a 1, a -2, and a 2. And then I do my second quit, and I go back and I say second matrix. And what I want is math this time. I'm going to scroll over to math, and it has determinant as the first item. So I want the determinant of matrix A. So go back and I pull matrix A, and I hit enter, and that number is -89. And I can do the same thing for the other two matrices that are included in this lesson. The answer key has the results. I'm not going to go through the calculator steps because it's the same calculator steps. All right, now going back to the lesson, the identity matrix is a matrix that has just ones all along the main diagonal. So if you see here, ones along the main diagonal, ones along the main diagonal. In order for it to be an identity matrix, it must be a square matrix. It must have the same number of rows and columns. Okay, so why do we care about the identity matrix? Well, what's interesting about it is if I were to put these matrices in my calculator and multiply them, when I multiply by the identity matrix, I get back the exact same matrix that I started with, and I can do it from either side. Here I had my identity matrix on the right. I still came back to what I had with my original matrix. Here, my identity matrix is on the left, and when I multiply, I'm going to get out the same exact matrix that this time is on the right. So the identity matrix allows us to multiply and get back the same matrix.